welcome to live session, first live session on the course network analysis, and whatever topics have been uploaded till now, I will request you to be in those topics only, so that in the second live session we will have the questions from others. In the meantime, I received some questions. Most of them are really not related with the course, so I will not going to answer individually to those questions. Now, one Mr. R. Ganesh has asked two interesting questions. First, I will take those two questions. He is asking that whether KCL, KVL should be applicable for high order frequency in network. Please explain. If I have understood the question correctly, he is trying to tell, suppose in a network there may be AC sources having all types of parameters R, L, C and things like that. He is asking if the frequency of this supply is very large, of course, he has not mentioned, whether still I can apply the KVL, KCL concepts in such networks. One thing is should be understood very clearly, that if the frequency is too high, such that the wavelength is not comparable to the dimension of the circuit, then you cannot apply. What happens is this: whatever is energy associated with the source, a part of it will get radiated for very high frequency, megahertz, this, that. Therefore, dimension of the circuit is to be considered in relation with the supply frequency. For example, for 50 hertz network, that is our main concern in network analysis. Whatever experiments you do in the laboratory, amount radiated is insignificant, and we say that okay, all energy supplied by the source is consumed locally by the resistances. Anyway, if you have understood it correctly, it is like that. He is also asking, same Mr. Ganesh, you are also asking that to explain series parallel RLC resonance circuit. I have discussed in the network courses, but nonetheless I would like to tell you like this, series resonance briefly, so that you can recollect series RLC resonance. What happens is this: suppose you have an R, an inductor and an capacitor in series, and suppose you have a source, some Vm, or say in terms of Rms value root 2 V is the peak value sin omega t, and you want to find out what is the current in the circuit. Okay, the current in the circuit for so for this frequency omega, first of all you have to find out the replace this L by omega L, j omega L, and this is by C should be replaced by minus j by omega C, reactances, so that the impedance of the circuit will be R plus j omega L minus 1 over omega C. Now, suppose if you have connected an ammeter here, which will record the RMS current for a fixed voltage, and if you go on varying the frequency, the question is how the current waveform will look like. Obviously, when this, and if you sketch this thing, and that is the reactance values of the inductance as a function of omega, it will be omega L, which will be a straight line, is not the reactance. So, this is XL, which is equal to 1 over omega L. Similarly, if you sketch the capacitive reactance, this is XL, it will be 1 over omega C, means omega equal to 0, it will be 0, infinitely large 1 over omega C is your X C. Its value will be infinitely large, and for very high value of omega it will be 0. So, its characteristics will be somewhat like this, asymptotically meeting. So, and the magnitude of the RMS current I happens to be equal to the RMS value of the voltage, which I am not changing. This is the RMS voltage applied, RMS voltage applied. So, V divided by the impedance of the circuit, for any ordinary value of omega, it will be under root R square plus your 1 over omega L difference 1 over omega C whole square. This sign means difference, omega L minus 1 over omega C whole square. Now, obviously, if and this frequency, at this frequency you see, this is called resonance frequency, and you can obviously see that if I will be maximum, I will be maximum when impedance is minimum, and that happens when omega L becomes equal to 1 over omega C, or omega is equal to 1 over root over L C. So, this omega naught is nothing but 1 over root over L C. It is at this frequency this circuit offers least impedance and current will be maximum. So, below this if you sketch try to sketch the current waveform against the same omega RMS value of the current, it will be somewhat like this. For example, if I go to next page and draw it nicely, it will be like this. This is omega axis, this is your XL, inductive reactance which is equal to 1 over omega L, this is 1 over omega C, capacitive reactance, only the magnitude I am plotting here, and this is the expression of the current which is equal to RMS value of the current V divided by, for any at any frequency omega, is this R square plus omega x omega L difference 1 over omega C whole square. So, at omega is equal to omega naught, this is the resonance frequency, and this is this axis I have sketched reactance values as a function of omega reactance of the coil as well as of the capacitor. Now, below this if you sketch the RMS value of the current will be maximum if omega, for example, is very large. If you keep the circuit before you, if you keep the circuit before you, you can easily see, suppose omega is 0, that is you are applying DC voltage. What will be the steady state current drawn from this? Then this capacitive reactance will be infinite. So, it will behave as a open circuit and there will be no current. So, omega equal to 0, no current. And suppose if omega is infinitely large, then also impedance will be infinitely large, current will be 0. Therefore, the current response, RMS current response will be somewhat like this here. it is at this omega naught maximum current will flow in this one, and this is called the resonance frequency phenomena. Of course, one can find out the half power frequencies, frequency band width of this one for the series RLC circuit. Please after this go through books or notes where most probably I have discussed this. So, current is maximum at the resonant frequency. So, this is called series resonance circuit. Now, if you consider a parallel resonance circuit, and what about the phasor diagram? Let me say that phasor diagram of this circuit is at resonance at resonance the impedance offered by the circuit will simply become R, because omega L is equal to 1 over omega C at resonance. So, it will behave like a resistive network, and voltage and current, the time variation of the voltage and current, they will be in phase. That is the thing. Is that point clear? So, this is in short the series resonance. Similarly, in parallel resonance in general, while introducing, suppose you say that you have connected one R and one inductor. These are perfect elements, pure inductor, pure R, and a pure capacitance in this circuit. And here once again you have parallel resonance. So, R, this reactance is omega L and this reactance is 1 over omega C. And here you have applied a voltage, say root 2 V sin omega t, with this is plus, this is minus. Now, the current across each element is same voltage divided by R. So, here we want to calculate this current drawn from the supply, and to draw the current drawn from the supply, it is better you can write the admittances, because potential of this, there are only two nodes. Let this node be called node A and this is 0. So, and let to get the RMS voltage very quickly, I will do like this: V bar is equal to V angle 0 degree, V is the RMS value of the voltage sin omega t, and then I will say that this current and this current is equal to the current drawn. For example, I will say this is IR, this is IL, and this is current in the capacitive branch. Therefore, total current drawn from the supply I will then become equal to V angle 0 degree divided by R plus V angle 0 degree divided by J omega L inductive reactance, and this is minus. So, plus V angle 0 degree divided by minus J by omega C. In other words, 1 by R can be thought of the admittance of resistance, 1 by J omega L is admittance of this one. So, this can be manipulated. You can write it as V 0 degree like this, then this will be 1 over R, and this is plus 1 over J omega L like this, and this is if I make a mistake you can just point out minus omega C by J like this it comes out to be, and J you bring it top. So, this will be this voltage divided by 1 by R, and this will be minus J by omega L, multiply j, numerator denominator, j square minus you bring, here also you multiply with j. So, it will be plus j omega c, is not, this will be the thing. Now, in this case what happens is this, this current, magnitude of the current once again is like this, V 0 degree, and this one can be written as 1 by R plus j omega c minus 1 over omega L, is not. So, in this case also, if I want to sketch the current drawn at different frequencies, the RMS current drawn from the supply at different frequencies, suppose I am going to change the frequencies omega here and omega, these two terms get affected. And once again at omega c equal to omega L, something happens. See, voltage multiplied by this factor is nothing but V angle 0 degree, and this factor is under root 1 by R square plus omega c minus 1 by omega L whole square, is not. This is the magnitude of this. So, magnitude of the current I will be magnitude of the voltage divided by into the magnitude of the admittance. Now, once again you see, when omega is equal to 0, for example, this is omega. When omega equal to 0, this term will not be there, and the admittance in the circuit admittance at omega equal to 0 will be how much? Root over 1 by R square omega 0. So, this term is infinitely large, is not, plus infinity, 1 by omega L is there. Therefore, admittance will be infinite. Therefore, at omega equal to 0, current will be infinitely large. Why? Physically also we can see, omega equal to 0, omega L it is shorted, these three are in parallel. So, voltage divided by all the currents will flow like this, therefore, infinite. So, current will tend to infinity. So, very large current at omega equal to 0, very large current. Similarly, as omega tends to infinity, omega is also very large, suppose. So, at omega equal to 0, as omega tends to infinity, then also the admittance tends to infinity because of this omega c term. Therefore, once again voltage into this infinite admittance will cause large current, and physically that is also correct. If omega is very large, then inductor impedance is very high, almost open circuit, and 1 over omega c, capacitor becomes shorted. So, current drawn once again will be very large, is not, and current drawn will be so, here is the thing. So, current drawn in this case will be something like this, current tends to infinity at omega equal to 0, this is I, current drawn from the supply as you change omega. At very large frequency also it will be infinity, and in between there will be some currents, but only thing is current will be minimum, I will be minimum, I will be minimum when omega c becomes equal to 1 by omega L, or omega becomes 1 by root over L c. and this is called resonant frequency in this context. Because it is at this frequency admittance, the circuit will be once again purely what is called, will behave like a resistive circuit, and at omega is equal to omega naught, imaginary part will vanish, and the current in the circuit is simply V divided by R, because this part then goes, imaginary part of the impedance will not be present, and this will be V by R, that is all. So, this current is V by R. So, minimum current. So, minimum current will occur as a, but nonetheless this is unity power factor at this point. Now, I will leave it to, for example, if it is at resonant frequency, if the operating frequency is greater than resonant frequency, whether the circuit will, for example, in the series circuit that I have done right now, suppose this is the unity power factor operation. Why? Because Z is equal to R at omega is equal to omega naught, that is fine. What happens if omega greater than omega naught? Suppose the operating frequency is here, then you can easily see if it is greater than this, omega L, magnitude of omega L is greater than 1 by omega c. So, it will be a lagging power factor operation. So, this is unity power factor at this point, and this side will be lagging, and this side will be leading power factor, leading. Who wins, whether omega L outsmarts 1 over omega c, then it is lagging, as we know. Opposite thing happens in case of your parallel resonance. If it is at unity power factor, whether this side should be leading or that side should be lagging, that I leave it to you to decide upon whatever I have discussed. Anyway, this is also called a resonance condition in the sense that it is like that. Only one interesting thing I will tell you, when in resonance, if I ask you at resonance condition what is the value of I, you will say the value of I is V by R, is not? That is what I will say. What is the value of IL and IC? Because at resonance frequency, what will be the current in this branch? If I want to ask you, you can easily see this, if this is the Phasor diagram, supply voltage, resistive phasor resistance current is IR, capacitive current IC will be leading this voltage by some angle IC, and inductive current will be like this. At resonance, IC equal to IL, and this IR will be in phase with V. Similarly, in the resistive network, I could also draw the Phasor diagram. This is V, this is for at resonant condition. If you want to draw, this will be IR, I is in phase, and voltage across the inductance will be this much, at resonance, that is j omega L into I. Current lags the voltage for an inductor, and for capacitance it will be like this, minus j over omega c into I, and at resonance these two lengths are equal. So, applied voltage is this voltage plus this voltage, and once again negative capacitor voltage. will be equal to V will be actually here, this length will also represent V. You must understand this. Anyway, any other question, Professor? So, now go through books. Is there any internship available, how to study with full concept? Acha, one of you have asked, okay, it is interesting question, that is D. Nikhil Santosh. You have asked a question which says that how to study network analysis with full concept and with application, because it is not easy to remember all concept of all the subjects. Okay, it is true for all the subjects, but in network I can only advise you this much. See, network problem is, if you look from the very beginning, it is like this. There will be several network elements R, L, C and several sources connected, and there will be a network. And the first problem is, if the sources are given, how to find out the currents in various branch. Okay, as I told you, in your school days you have learned about KVL and KCL, okay? And of course, you did not know anything about current source, it is expected. Only battery, voltage sources, also with AC, DC, you have done that. And one good thing about any network problem is this: whether it is DC circuit, whether it is AC circuit, whether it is linear, whether it is non-linear, whether there are dependent or independent current sources, voltage sources present, KVL will be always satisfied and KCL will be always satisfied. And if suppose I have decided I will not learn anything beyond that, you can leave, you can find out the current, struggle, write down big equations, KVL, KCL at nodes, several currents and so on. You will be able to solve the circuit. But it is very likely, if the network is slightly complicated with many branches, many nodes, then it is invariably will make some mistake. Okay? So, so people then start learning about useful techniques by which one can solve the network. For example, can I write the KVL, KCL quickly? I will follow some rules, and rules are very interesting based on KVL, KCL only. Or if I want to solve a complicated network, if the node voltages are known, I have practically solved the circuit. These are the important concepts. And another important concept that, since you have asked, I will tell you, whenever you solve a network, so far as the exam purpose is concerned, it is expected no one is going to give you a very big complicated network to test you that you know circuit analysis. There may be intelligent questions where, for example, you should not forget that in any network the energy balance must take place. There will be several sources, there will be several impedances, resistance and energy storing elements, inductance, capacitance, etc. At every instant, energy supplied by the sources, energy consumed by the resistances never store energy, and resistance stored in inductor and capacitor, they must balance. That is, amount of energy pumped into the network by various sources at a given time must be equal to, at that time, the power losses in the resistances and energy stored in the inductors. This is one very conceptual thing. If you remember, solving of network problems will also become much more, with pleasure you will be able to solve the network. Always cross check, okay, networks will not be big in exams, as you know. So, these concepts are important. Similarly, Thevenin's theorem, the powerfulness of Thevenin's theorem, and it need not be emphasized. Very complicated network across 2 points, so only one source, one impedance in series, provided the network is linear, etc. Similarly, a big network can be visualized across any 2 points as a current source in parallel with some impedance. These are very interesting and useful concepts. Similarly, other theorems like Telegen's theorem, then what is called your theory of reciprocity. Given a problem, try to see whether you can apply those techniques efficiently. So, these are the things you behind all those mathematical steps, mentally you should be understanding those theorem. Okay, in this case I can apply that. Anyway, go through the course, further we will discuss about this. Somebody asked about quality factor. Most probably I have not taught this in the class, but I will only tell that quality factor of a coil, it has something to do with the resonance condition of the circuit. See, suppose in a circuit, if I go on reduce the value of R here in this resonance circuit, this is for one value of R at unity power factor, this peak current is V by R. Now, suppose I will carry out the same experiment, that is I will vary omega, but reduce the value of R. Then this curve, are you getting, this is one value, say R equal to R1. Now, the same response, type of response I will get if I choose lower value of R, I will get a curve, because then the, in simple term I am telling, this current, then first time it was V by R1, I have reduced this R to R2, this is R equal to R2, R2 is less than R1. Then this peak current will increase, is not? In this way, if you go on, that is lower and lower value of the resistance, then this curve will be very sharp around this omega naught, it will center around. For other frequencies, response will not be so sharp. That is the ratio of omega L by R. In loose terms, I can specify the quality factor of the coil. If R is vanishingly small compared to omega L, then at resonance it will be infinitely large. Right now I can tell you this much. If time permits, in the course I will take up this one in detail. That is the sharpness of this curve, how good this coil is, that is omega L, how many times it is greater than the resistance, that decides the peak value of the current here. In short, it is like this. Acha. Another fellow asked another question. Doubt in first and second, some Pratik you have told doubt in first and second order differential equation, and Nirnimesh has given a problem to solve for you here. Okay, that I am not sure, I will only tell you the ideas. But about you have just simply told doubt in first and second order differential equation. I really, one may have doubt, but exactly what kind of doubt I do not know, but I will just try to tell you differential equation, linear differential equation, mind you, differential equation. In short, it is like this. Suppose you have a differential equation d2y dt2, second order, first order I am not writing. First order differential equation is like this. Okay, let me write a y is equal to a forcing function on the right hand side. A second order differential equation is this a dy dt plus a by is equal to, it is also excited by xt. So, this is first order and this is second order. Second order. The second question also that he gave some equation with a forcing function. He is asking me most probably to solve this, but you go through what I am telling now, so that you will be, that is Nirnimesh. Please, your attention also please. Now, what exactly I am telling is x t is the forcing function. In the first order differential equation, the order of this d dt decides the order. So, it is first order because d 1 this is 2 second order and so on. Now, the question is to solve a given linear differential equation, you can adopt several methods. In fact, Laplace transform method one can adopt by remembering some formula. But what I am telling, for example, if I put some number dy dt plus 3 y is equal to suppose some t square, and it is given that y 0 is equal to 1. I have been asked to solve this circuit. What I am telling, even if you do not know Laplace transform, the solution of this can be very easily written just by inspection. What you have to do is, the first step is write down the characteristic equation, which is you know, m plus 3 is equal to 0. That is, this one is d plus 3 into y is equal to t square, where d is equivalent to d dt. Okay. With forcing function equal to 0, right hand side 0. So, so this d you replace by m, just for your purpose it is equal to 0, and find out the roots minus 3 in this case. And the solution of this network will consist of two parts that you must remember. One is called the transient response, y t will be y n t natural response when x t equal to 0, here this is x t, and another is solution due to forcing function. Now, the rule is very simple. It says that if you have found out the characteristic roots, the natural response will be some constant which is to be determined into e to the power minus e to the power m t, which happens to be in this case minus 3 t. That is the natural part of the solution. And what is the solution due to forcing function? That is due to this part. It will be a linear combination of, say, k 1 x plus k 2 x dot plus k 3 x double dot plus up to infinity, linear combination of the forcing function and its higher order derivatives. So, in this case situation is very simple, minus 3 t, this is the natural response, and then in this case it will be equal to plus k 1 into t square plus k 2 into x dot is dx dt, mind you. So, dx dt is 2 t into k 2, let that be the k 2 into t plus k 3, differentiate this further to get x double dot, which happens to be constant, is not, k 1 k 2, oh k 3, then k 3 differentiate t square twice t then once again you differentiate, it is a constant, is not, k1 t square, k2 t plus k3. This will be the terms you expect to be present in the solution, clear. So, these are the things here. Now, you have to apply the boundary condition to get the constant. But one thing, how to determine so many constant? The question is this one. You must understand that the solution due to forcing function alone will satisfy this equation. Key point to be noted is forcing function solution due to forcing function alone. What is that solution? That is y f t. This y f t will satisfy this differential equation. Y f t satisfies, y n plus y f t satisfied, y n t will sum up to 0. Therefore, I will simply satisfy this y f t there in this equation and put it there to find out the constants k 1, k 2, k 3, because that will be an identity. So, after I have solved k 1, k 2, k 3, I will put it here. Then finally, this value of A is to be determined from the boundary condition given. Is that clear? I think Nirnimesh, you please try to solve the problem in the same way as I told you. Only thing is, if the forcing function happens to be one of the roots that I have discussed in great length in my lecture notes, please go through it. I hope you will be able to solve this problem d2y dt2 plus 5 dy dt 6y etc. I will request you to once again to try to solve and mail me your solution. Personally, I will mail you. Yes, any other question? One of you asked from which element dependent sources are made of. I will in fact take up this topic in few days time. So, right now I am not discussing it. Only thing I can tell, okay, dependent source, if you have a transistor operating in active region, for example, the collector current is beta times the base current, no matter what is the resistance of the collector. Therefore, it looks like a dependent source is present in the collector circuit. Anyway, we will discuss this. Acha, one student asked, is it possible to remove transient from a second order network excited from AC source? Yes, this is very interesting question. We know that it can be always removed. For example, suppose you have this, I will just qualitatively tell you. Mathematically also it will come same. Suppose you have an RL circuit, R and L circuit, and here is a switch. Where I will supply some sinusoidal voltage. With peak value root 2V. Now, the question is, in this network problem, if I start solving it, assuming this to be the current and assuming this to be V max sin omega t, suppose let us assume V max sin omega t. Acha, if this is the voltage means, and the switch is closed at t equal to 0. Now, I have put one restriction on the supply voltage here. Let us try to understand this. This is the sinusoidal voltage like this, and I am counting my time from this instant t equal to 0, this axis is omega t. So, when t equal to 0, the equation of this circuit is then V max sin omega t only, no. I have applied this, and let us assume the current through the inductor at t equal to 0 minus was 0, and I want to find out the current in the circuit for t greater than 0. So, what I am going to do? I have to write down the KVL equation, which I will tell you it need not be written to physically understand what is happening, but let me tell you what are the steps I will be doing. L di dt, suppose I love mathematics, I want to solve the network, okay, I write it like this. At any time, this is the equation B max sin omega t. Then what I am going to do? I divide by L both sides, so that it comes to this one by L. Then the right now I told you, then the characteristic root I will write straight away is minus r by L with right hand side 0, m plus r by L is 0. So, minus r by L, and then I will say that okay, the solution of the network, see this is the beauty of the classical way of solving circuit. I do not have to go to Laplace domain etc. I will looking at the right hand side and the characteristic roots, I can straight away write down okay, solution will be like this, this will be the natural part of the solution, and the transient part, this is the transient part, natural solution which is called, and the solution due to forcing function is the linear combination of the right hand side. So, x t sin omega t, differentiate x t, you will get cosine omega t. Once again differentiate it, you will get sin omega t. So, you will get infinite terms no doubt, but they will involve sin omega t and cosine omega t. So, this can be assumed to be c sin omega t plus d cos omega t, where c and d are constant. You have to find that out. So, here 3 constants are to be found out, a, c, d. Now, as I told you, to find out the constants of c and d, this itself, this is solution due to forcing function except t. This alone satisfies this. Put it here, equate the coefficient of sin omega t and cosine omega t from both sides, solve for c and d, you are done. After you have solved it, total solution is this. Then put this boundary condition, I 0 minus is equal to I 0 plus 0. Is that clear? So, this is the total solution. Now, I will tell you something more. So, if I know the classical approaches, tell me this one. Now, look at this problem from this point of view. Suppose you have, let me not draw the supply voltage. Let me tell you where is the error. Suppose, see supply voltage is present like this omega t, and here is your circuit. You must understand this step. I do not know when I am closing the circuit, because I cannot see the supply voltage. It may so happen I am closing the circuit at when voltage is passing through 0 and maximum, or voltage is passing through 0 or minimum. Now, whatever it is, the steady state current of this circuit can be found out as I steady state, that is the solution due to forcing function is the steady state current is root 2 V by Z sin omega t minus theta, where tan theta is omega L by R, is not. So, steady state current I sketch here. this is I steady state and this is the power factor angle. Now, listen carefully what I am telling. Suppose you are closing the switch at omega t equal to 0, do your mathematics, get the solution, but what I am telling, you will get the, because inductor current cannot change instantaneously, there must appear a DC current which is dictated by the DC steady state current at omega t equal to 0, that will appear to satisfy, to make I 0 minus equal to 0, and this fellow will decay down. And addition, this is the transient part of the solution. So, naturally, and this angle is theta. Naturally, if this is your, this is the last thing I am going to tell. If this is the, that is the question you have asked, if this is the current, say blue, let me draw, steady state current, you draw from this is the power factor angle. Steady state current is the solution due to forcing function, you must understand ISS. Now, if suppose somebody happens to close the switch at this point when the voltage magnitude was positive and this much, then I 0 minus and I 0 plus will be same automatically, and there will be no transient part. By that what do I mean? Then you will get the constant value A to be 0. So, if you happen to close the switch at omega t equal to theta, then you can easily see that part will vanish. I think you have got the idea, you do it. Any other question, Professor Chatterjee? Somebody asked power factor is the angle between voltage and current or ratio of real power and apparent power. Which way is right? Now, power factor angle is the steady state current in AC circuit, this is the formal definition, this is the voltage and this is the current, steady state current, mind you. Suppose this is the steady state current. This is the instantaneous voltage, instantaneous current in an RL circuit. Always draw the circuit and see which current, which voltage you are showing. That is a good practice in dealing with networks. This is R, this is L. Now, the RL circuit we have seen by this angle it will, current will lag, and this theta is called power factor angle, power factor angle, power factor angle. Now, the question is, there are two sine waves, one of them lags other, where that power business comes here. You could simply say current waveform lags voltage waveform. Why that theta has also become a power factor angle, most probably that is your perhaps question, is this. See, the power in this circuit, instantaneous power, is power delivered to the circuit will be product of V into Y, is not? That is equal to V max, suppose sin omega t, into I max sin omega t minus theta. Still I do not know why should I call this theta to be power factor angle, that is what I am telling. So, what you will be getting, instantaneous power is V max into I max, this is I max, and you will get sin omega t minus theta, that is what you will be getting, is not? Now, this instantaneous power, if you see, if you this multiplication operation, if you do at every time, you can easily see, first draw some vertical line at the 0 crossing of the voltage, either voltage or current. Between these 2 points, voltage is positive, current is negative. So, power will be negative, something like this. During this interval, voltage and current both are positive and for a long duration. So, during this time you will get a curve like this here. What I am sketching? Instantaneous power like this. Then see the next zero crossing is here. So, here once again voltage, current is positive, voltage is negative, negative power, something like this. So, it will be something like this. So, average power of this waveform is not 0, you can easily see visually. So, there will be some average power. How to calculate this average power? So, P average, if you calculate, it will be how to calculate average power or two quantities V max, I max, average of sine, these are constant, sine omega t minus theta over a complete cycle 0 to 2 pi you integrate and divide by 2 pi. This integration you have to carry out. This integration very easy to calculate. I will take a rather black color. How much it will become? P average then will become you multiply and divide by 2. So, V max, I max by 4 pi and 0 to 2 pi mind you over a complete cycle 0 to 2 pi. So, 2 sin A sin B, it can be broken up as cosine A minus B minus cosine A plus B. So, that will become cosine of A minus B is cos theta and cosine A plus B minus minus cosine A minus B minus cos A plus B. So, that will be 2 omega t minus theta and whole thing d omega t. Now, this theta angle is a fixed angle for a given circuit. So, P average that is this line I am calculating how much it is. P average will be V max, I max by 4 pi, cos theta can be taken outside and this integration first term will be d omega t only, cos theta is constant can be taken outside minus this integration that is V max I max by 4 pi and integrating this cosine 2 omega t minus theta d omega t over a full cycle. What is the value of this integration? It will be 0 because it is a cosine function and double frequency. So, cosine function integrated over a full cycle has to be 0. So, this integration need not be computed. So, it will come out to be this and this will be then V max. So, this integration is 0 anyway you calculate that. So, V max I max by 4 pi and this integration is 2 pi which means V max and cos theta is there mind you. This theta is this 0, let me write here 0 to 2 pi and there was cos theta here. So, V max I max cos theta divided by 4 pi and this integration is 2 pi. So, 2 pi goes here 2 comes. Now, this V max this 2 can be absorbed in V max by root 2 into I max by root 2 into cos theta and it comes out to be V I cos theta, where V is the RMS value of the voltage, I is the RMS value of the current and theta is the angle by which current lags the voltage. Now, then we discovered that in DC circuit power is voltage into current. In AC circuit with energy storing elements we find that okay, it will be voltage into current into some factor whose value can be between 0 to 1. So, compared to that, so logically people have named this sin theta as power factor. By additional factor, you have to multiply the product of voltage and current to get the actual. I hope you have understood me. Read the books, see my notes, and I hope that will be okay. Is it time? So, anyway, thank you very much for being with me. I do not know how far I could satisfy you, but it is good to have live sessions so that I know your minds. You please communicate through mails, your queries, then also I can tell. For example, after attending today's session, I think I will spend at least one lecture in detail for the resonance circuit. Whether I have done it or not, I am not sure, because it was analysis side. Anyway, I will take care of that. Thank you very much.